If you are planning on working on older electronic devices such as radios, old stereo equipment, tape recorders, all kinds of audio gear and test gear, you need to get an isolation transformer. It is not just a nice thing to have. It is a must thing to have for safety. I use my isolation transformer 100% of the time. This is the isolation transformer that I have on my workbench. And here's a closer look at the specifications. The isolated side will produce 1.5 amps of 120 volts AC 60 cycle. And here is the diagram of this isolation transformer. The primary side, the left side, is connected to commercial power, and the secondary, the right side, is the isolated power. And the two are coupled only magnetically, so there is no direct electrical connection between those two coils, which isolates the secondary from commercial power. When I am working on an open chassis, that radio or record player or turntable, you name it, whatever it is I'm working on is plugged into that isolated power. And like I said earlier, 100% of the time. Now, of course, I can still get a shock, but I will not be connected to that very powerful commercial power. Also, if I need to use an oscilloscope or a VTVM and they're plugged into the commercial power, there is no possible way that I'm going to have a direct short through that test equipment to the chassis that I'm testing, because the chassis is isolated. You can construct an isolation transformer by using two transformers that came from a high tube count radio, or better yet, a high tube count TV. As you can see, on the primary side we've got the commercial power, 120 volts. On the secondary side we have a high voltage winding. We also have a 6-volt AC winding, and we also have the 5-volt AC winding, and that is a high current winding, and that's the one that we're going to use. Need something like this. A great big old transformer, very heavy. Need a couple of those. Here is the diagram of our two power transformers. All the leads that are marked with red X's should be taped up and stored away. They are not going to be used. What we're going to use is the 5-volt AC. We're going to connect those together between the two transformers. And now when we do that, we have our isolation transformer. We'll have 120 volt commercial power on the left transformer, and the right transformer will produce 120 volts, maybe a little bit less, of isolated power on the right hand side. Now for testing, I would set it up like this. I would have a 1/4 amp slow blow fuse And of course you could wire a switch in there too if you wanted to, on the commercial side. And I would let it run to see if either one of the transformers overheated, just in case you have a bad transformer or you have a bad mismatch for some reason. When it passed that test, I would replace the 1/4 amp fuse with a 1 amp fuse, slow blow, possibly 2 amp, but I'm cautious. I would use a 1 amp slow blow. And then I would plug into that a 100 to 120 watt bulb and let that run, continuously monitoring both transformers for about an hour to make sure that neither one will overheat. And when you pass that test, you've got a good setup for your isolation transformer. So if you're going to be working on open chassis, you need to buy an isolation transformer, or you can construct an isolation transformer.